All right, guys. So continuing on with our look at polynomial functions, I want to look at some things that are called zeros of a polynomial function, and it works something like this. Let's look at a graph of a parabola real fast. I'm gonna put it something like this. That's pretty good. So there's our parabola going like this, and I'm going to tell us that the equation for this parabola is x squared minus 2x minus 8. So what I want to do for a second is I'm going to take this, the equation for this, I'm going to set it equal to 0, and then I'm going to solve for x. Just kind of go with me for a second, okay? So x squared minus 2x minus 8 equals 0. So let's solve for x. We got to factor it, so let's do this. And we'll get x and x, minus 2 and minus 8, minus 4 and plus 2. There we go. And then so then we can set each one equal to 0. So x minus 4 equals 0, and x plus 2 equals 0. That's how we solve these things. And then plus 4 to both sides, so x equals 4, and x equals a minus 2. So these right here are what we call the zeros of this function. And essentially they're the numbers that if we plug in this value into the function, it would make it equal to 0. So if you plug in 4 in here, it would make this equal 0. And you can check and it would work. If you plug in negative 2 in here, it would make this equal 0. That's what the zeros mean. All right. And so when it comes to the graph, though, the zeros of the function are the x-intercepts. There's our minus 2, and there's our 4. All right? That's how that works. All right? The zeros and the x-intercepts, so these right here, they're the zeros, but they're also the x-intercepts. Right? That's kind of how that works. The zeros of a function are the numbers that when you plug it in make it equal to 0. So if I did f of 4, this would be 0. And then on a graph, that kind of corresponds to that's where the x-intercepts are. Okay, and so the way this is kind of useful because if we were ever told here's the zeros of the graph, we can kind of what we can do with that is we can from the zeros we can kind of construct the equation for the graph. For example, what can happen is they can say, here's the graph whose zeros are, negative 2 and 4. If I know the zeros negative 2 and 4, find the function. Find the function for this. And the way we would do that is we say, okay, well, I know that to find the zeros, this process had to happen. This solving for x and all that had to happen. So when all said and done, it would have ended up being x equals negative 2 and x equals 4. Well, I'm going to make, these were both set equal to 0 at some point, so I'm going to move these numbers over. So it's going to be x plus 2 equals 0 and x minus 4 equals 0. Kind of working this process backwards. So these two things, x plus 2 and x minus 4, those were the two factors when we factored it out. So I can do x plus 2 times x minus 4 equals 0. And then I could FOIL it. I could FOIL it out. And when I do that, I would do, x times x, and that's x squared, and x times minus 4 is minus 4x, and 2 times x is plus 2x, and 2 times minus 4 is minus 8, equals 0. And then, oops, sorry guys. And then combine some like terms right here in the middle, and so I get x squared minus 2x minus 8 equals 0, and there's our function, okay, our f of x equals x squared minus 2x minus 8. And so because we started off with these are the zeros and make me a function, I know now for a fact that this function is going to have x-intercepts of negative 2 and 4. That's kind of the advantage of all this, is kind of start off with, I want a function that has these x-intercepts, give me the function. And that's how we can do it. Okay, let's try another one just to kind of make sure we got this okay. So let's go this way a little bit. And so what we'll do is we'll look at, let's look at x cubed minus 6x squared plus 9x, f of x equals all this. And find the zeros of this. So find the zeros of this, what's going on. Let's clean this up a little bit here. Here we go. Okay. So we're going to find the zeros for this function right here. So let's see what we can do. We got, first thing I can do, it looks like I can factor out, well, I can set it equal to 0 first, x cubed minus 6x squared plus 9x equals 0. So we can factor out a 0, it looks like. So let's do, or factor out an x. Okay, so I can go x times all this stuff, and it would be x squared. X times x squared is x cubed. Minus 6x, x times minus 6x squared, plus 9 equals 0. Now I can factor this piece of it, and it looks like that's going to be, it looks like it's a perfect square. It's going to be x minus 3 times x minus 3. All right, and then now I can go ahead and solve these. So it would be x equals 0, x minus 3 equals 0, and x minus 3 equals 0. Okay, so x equals 0, that's kind of done. We have that 0 already. This is going to be x equals 3. There we go. And we're going to have x equals 3. So our zeros are going to be 0 and 3. Because, I mean, we wouldn't write it twice because it's only going to cross the x-axis one time at any one x value. So it's going to cross 3 only the one time. But if there's something wrong here, if we just stop and say the zeros are 0 and 3, that kind of leaves out some information. Like here, if I said, here's the zeros, 0 and 3, find me a function, we would only put one of these in there. I mean, but it looks like we had two of them, you know. So here we had this factor of x minus 3 happen twice. But if all I gave you was the zeros 0 and 3, we'd only, if we started to work the problem out, we'd say, okay, you know, x equals 0 and x equals 3, and then work the process like that. So how do we say that this happens twice? Well, the way we say that is when the 0 it showed up 2 times. The way we do that is we say that this 0 right here has a multiplicity. It's called multiplicity. Has a multiplicity of 2, meaning that it happened twice. It showed up 2 times when we factored it all out. Okay, so when we solved it all out, so it happened twice. So then we had, so there's our 3 zeros, 1 here and 2 here. So there's our 3 zeros we got, because it's 0 has a multiplicity of 1 and 3 has a multiplicity of 2. Okay, so well, now what does that mean for the graph of this? Well, here's how it works. All right, let's talk a little bit about multiplicity just for a second. If a graph or if a function has we'll say an even multiplicity, even multiplicity, and then we've got odd multiplicity. That's going to be the choice here. So either even or odd multiplicity. If it's even multiplicity on the graph, what's going to happen is like on the graph of the thing, let's say this is the 0 right here, the graph is going to approach the x-axis, touch it, and bounce off. It's going to touch the x-axis and then curve away from the x-axis like that. So bam, like that. That's going to be what happens when there's even multiplicity. It touches the x-axis. All right, so it touches x-axis. Right. So some people say it bounces off. So it touches or it bounces. And then now, if there's an odd multiplicity, it would do something like this. It would go like through the x-axis. All right, they're still both x-intercepts. They still touch the x-axis here, but with an even multiplicity, it touches it and bounces off. For an odd multiplicity, it goes right through it at that point. I'll say it crosses the x-axis. All right, so even multiplicity, it bounces off. Odd multiplicity, it crosses through. Okay, and so here's what we can do with that. Let's say we're given a graph. Let's be given this graph right here. Let's be given the graph that looks like this. Here, here, and here. So we'll call this, 0, and this is 1, and this is 2. So this is the x-axis here, and we'll draw the graph like this. There's the graph, this crazy W-shaped curve. We can actually, from this, create the function just by looking at the graph. And here's how it works. Remember, the x-intercepts are the zeros. So we have 3 zeros here. We have our zeros are 0, 1, and 2. Now the thing is, we know that there's something going on here, but what we can do is we can now write out the different factors. So we got x equals 0, x equals 1, and x equals 2. So this one's just going to be x. This one's going to be x minus 1. This one's going to be x minus 2. And then we could multiply all these together and stuff, all right? Now the thing is, we know that there's something going on with the different multiplicities. Here, these are going through, and this one's just bouncing off. So that means that these two, 0 and 2, these zeros, there and there, they only happen once, or they happen an odd time. But I mean, the easier way to do it is if you know it's odd, we're just going to say, okay, well, if we got this 0 one time after we factored it, it would be odd. Or I mean, we could write this as, you know, if this 0 showed up 3 times, it would still be odd. It would still go through. We're just gonna leave it as x and x minus 2. This x minus 1, it happens an even number of times because it bounces off. So what we're gonna do is we're gonna change. So this is gonna be x minus 1, but it happens an even number of times. We'll put it squared. Okay, and so this would be our equation. F of x equals x times x minus 1 squared times x minus 2. And that would be our equation for our function. And we could go an extra step and we could FOIL this out and multiply all this together, but that takes a bunch of steps. And the book a lot of times will stop right here, and I'm okay with us stopping right here. We could take it all the way, but we don't really need to. That would be the equation for this graph, because we know what the zeros are, 0, 1, and 2, and then we know that this one has an even multiplicity because it bounces off, so that's why we made it squared. And then we just cram them all together, and that's it. Okay, so hopefully that kind of clears some things up about zeros.